Okay, so in this section, we're going to talk about absolute convergence. So if the series n goes from 1 to infinity, absolute value a sub n converges. So if the absolute value of the sequence, and we take the sum so that the series converges, then what do we know? Then the series n equal 1 to infinity of a sub n converges absolutely. Very strong convergence, all right? Absolute convergence. Now, if the series n equal 1 to infinity of no absolute value, but just the regular sequence an converges, and the series n equal 1 to infinity of the absolute value of a sub n diverges. So the series itself converges, but when I put the absolute values on the sequence part, the an part, it diverges. Then the series n equal 1 to infinity of a sub n converges conditionally. Okay, it's conditional convergence. So convergence when some of the terms are negative, but so like some of them might be negative terms, plus minus, plus minus, plus minus, and so on. However, when I make all the terms plus, 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 then we see that the series diverges. This is conditional convergence, okay? Versus if I have everything positive, plus, 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 plus. Now, even if they were negative, they're now turned positive, and it still converges, then I know that the series converges absolutely, okay? Now, corollary here might be obvious, but I still need to write it for you. If the series n equals 1 to infinity of absolute value of a sub n converges, then the series n equal 1 to infinity of a sub n converges also. So just so we're clear, if you converge absolutely, then you definitely converge, okay? All right. Some interesting facts arise when you're talking about convergence in the absolute versus conditional convergence. Okay, so there's some interesting things that happen here. So what's going on here that's interesting? With absolute convergence, all right, you can add up the numbers in any order you want. And not only will it converge, but the result of the total sum will always be the same number. Okay? So here, like say we've got something like this. Series n equal 1 to infinity of 1 over n squared, okay? So this is equal to 1 plus 1 over 2 squared is 4, plus 1 over 3 squared is 9, plus 1 over 4 squared is 16, and so on and so on. This is equal to, okay, so that adds up to pi squared over 6, I think, maybe? Something like that. Whatever it is, it's some number, okay? Even if I took the numbers and I rearranged them, okay? So maybe I had like 1 over 100 plus 1 over 16 plus 1 over 64 plus 1 over 36 plus 1 over 4 plus 1 plus... And I'm just rearranging all these reciprocals of those squares, right? And I just add it up, forever and ever. I'm still going to get pi squared over 6, which is a pretty amazing fact, okay? The order in which I add here does not matter when the series converges absolutely, okay? However, an amazing fact, if it's conditional convergence, okay, conditional convergence, the order in which you add up the terms is very important. Very important. Why is it important? Okay, so if you rearrange the terms, then what? You will get a different result when you add up all the numbers. What? That is crazy. What is this saying, people? Conditional convergence? We're saying if we add up these numbers, that if we rearrange them, we can sum up to any number that we want it to sum to. That is an amazing fact. So think about this. Series n equal 1 to infinity. Let's do the alternating series. -1 to the n over n. Okay, what is this? This is what? Oh my goodness. Let's do -1 here. So this is like 1, and then minus a half, plus a third, minus a fourth, plus a fifth, minus a sixth, plus a seventh, minus an eighth, plus a ninth, and so on forever and ever, right? How can I add up to any number that I want? How is that even possible, right? So how is this possible? Say I just want to add it up to 2. Okay, say I want this to add to 2. How would I do this? Well, here's the game that I would play. I would say, all right, I'm going to add up positive numbers until I get 2 or bigger. So what do I have to do? 1, so that's one of them. Then I add a third, that gets me like 1.3. Add a fifth, so that's like 0.33, that's like 0.2. I've got to look at all these positive ones. 1 over 7 is like 0.14, I think. I don't know. We're going here. Okay, so 1/5, 1/7. Okay, is that going to be at 2 yet? So what do we have? 33 and 2/0 and 1/4 and 1/9, I think is like what, 0.11? We're not even there yet, right? So we keep adding and adding. So let's see, what do we need to add to? So I've got 1 plus 0.333 plus 0.2 plus 0.14 plus 0.11 plus, okay, 1 over 11 is 0.09, I think. And and then 1 over 13. Oh my goodness, I'm getting further and further away. So that, right now I'm at, I think 1.87 something. So 1 divided by 13, that's another 7. So you get the drift here, right? At some point, we get big enough that we get over 2. Okay, so let's see here. 1 divided by 15, that's 0.06. And then plus 0.07 plus 1.873. Okay, so that should get us there. So this barely gets us, if we add up these here, this gets us to like 2.009 or something. So that gets us right over 2. Now I'm going to put in my first negative. Okay, so put in a -2. So now I take care of that one. Well, what do I have to do? Now I have to start adding all these back in until, so like at this point, I'm back to like 1.5009 or whatever, right? So then I have to add, I got to keep adding till I get over 2 again. And then I go back and I pick up the -1/4. And I continue this game forever. And the sum will approach 2 if I continue that algorithm, okay? So it's kind of a very clever way to do it, but very interesting, very cool that you can take a conditionally convergent series and make it add up to whatever number you want it to, okay? When you're adding an infinite amount of things, magic can happen, especially when you're talking about a series that converges conditionally versus a series that converges absolutely. All right, guys, hope you found that as interesting as I did. All right.